Swayam Prabha. Digital India. Educated India.
Today we will start discussing about a very important topic in microfluidics, which is surface tension driven flows. As we have discussed earlier, that as we go down to smaller and smaller scales, surface effects become more and more important as compared to volumetric effects. So, there are possibilities by virtue of which one can exploit surface effects to a benefit, or surface effects may be used as a control mechanism for controlling or driving or actuating fluid flow. For example, when we think of a pressure gradient driving a flow, it is really a challenging proposition to create a good enough pressure gradient to drive a good amount of flow through a microfluidic system, because of huge frictional losses. So, what one can do, instead of using a pressure gradient directly, one can exploit a pressure gradient that is implicitly induced because of a surface tension gradient. So, it may be possible that naturally occurring surface tension gradients are there, or naturally occurring surface tension forces are there, or surfaces can be engineered to create surface tension gradient. And because surface tension occurs so nicely in small scale systems, it is very important that we study the behavior of surface tension or the characteristics of surface tension driven flows in general and surface tension driven microflows in particular. So, a brief motivation what I have discussed, that in small dimensions surface tension dominates over other forces. So, it is not that it is a very new kind of force, it is something which nature has been knowing for a very long time. Like if you think of the transmission of water from the lower level to the topmost level of a tall tree, how that is possible? There is no pump made by engineers by which water is pumped from the root to the topmost level of the tree. But how it is possible? It is possible by surface tension, it is possible by capillary action. So, because of the smallness of the capillaries, that we will see that because of the smallness of the capillaries, surface tension force can lift the water to a significant height, and that significant height is good enough for supplying the topmost branches of the tree with the necessary water that is sucked from the ground. So, there are many examples where surface tension forces are important, like one can use surface tension force to manipulate droplets, to manipulate bubbles, and these droplets and bubbles are also very important in microfluidics based applications. So, we will briefly revisit the fundamentals of surface tension, that is what is surface tension and why is it important. So, I will come to the board, of course it is represented in the view graph also, but we will utilize this view graph for mostly summarizing our observations, but just for simplicity we will not consider a complicated scenario, but consider a very simple scenario when you have a container, there is an interface, the interface separates the vapor from the liquid. Okay. Now, I mean whether the interface is flat or curved, forget about that at this moment, we will discuss about all these issues in much more details later on, but for the time being let us assume that the interface is of some form, some shape. Let us consider some liquid molecule here. When the liquid molecule is here, this molecule is acted upon by forces equally from all possible sides, because all sides are surrounded equivalently by other liquid molecules. So, there is equal attraction from all the sides. However, consider a molecule on the interface. When you are considering a molecule on the interface, what is happening? On one side you have liquid and on another side you have vapor. Which is more dense, liquid or vapor? Liquid is more dense. So, liquid being more densely packed, it is more likely that this molecule is attracted more strongly from the liquid side as compared to the vapor side. If that be so, then what is the possibility? Then the possibility is that this liquid, this molecule at the interface has a very special character. We do not call it liquid or vapor, but it is an interface, but it is also having molecules, and this molecule will have a tendency to dissolve into the liquid phase, but that does not happen, because if that happens, no interface can be formed. So, interface is formed, that means that the molecules at the interface are having, grossly speaking, from the system level, they are having some energy so that they can overcome that attraction, this net attraction, and remain at the interface. So, this is called as interfacial energy or surface energy. Now, not only that, how this energy is expressed, typically it is expressed like that. So, when you have an interface, because of this reason the interface is considered to be under some tension, and since the interface is considered to be under some tension, this state of the interface is described by a force which is also called as surface tension, and it is expressed in terms of force per unit length. So, the surface tension or the surface tension coefficient sigma between two phases is expressed as a force per unit length of the interface. So, its unit is Newton per meter. Okay. So, this is what is summarized in this view graph. So, you can see that like there is a volume element which is identified, and we are, that volume element crosses the interface or cuts across the interface, and we are seeing that there is a differential force or extra force towards the liquid as compared to the force towards the vapor because of the differential density. Okay. So, this is what we have discussed. I am not going to reiterate. I mean, this view graph discusses about what is surface energy and what is surface tension. So, of course, there are more formal definitions associated with this, but this is a qualitative way of understanding the concept which will be useful for us for our analysis. Now, we will of course start with a basic understanding of surface tension, but the question is, how can surface tension actuate or control fluid flow? That is what is of very important concern for us.